right, so let's look at the theory and our formulas for this. So using this as an example, it turns out that the sampling distribution of p hat, we have some qualifications. We want to have a simple random sample, SRS. We need to have independence in our sampling. So that's when n is less than 0.05. And if that's the case, and then we have population proportion p. So then mu of p hat, the mean of our sampling distribution, ends up being p. And the standard deviation is p times 1 minus p over n. And we take the square root. And both of these formulas will be on your formula sheet. All right, and then finally the shape of our sampling distribution for p hat is going to be approximately normal if, and this should look familiar to you, mp times 1 minus p is greater than or equal to 10. All right, so let's try this out really quick. So according to a time poll conducted in June 2008, 42% of registered voters believe that gay and lesbian couples should be allowed to marry. That was back in 2008. I'd be curious to see what that percentage is 10 years later. That would be something that we would do in Chapter 10, hypothesis testing. But coming back to Chapter 8, suppose that we obtain a simple random sample of 50 voters to determine which voters believe that gay and lesbian couples should be allowed to marry. All right, so a lot of words, always focus on that last sentence. We're going to describe the sampling distribution of the sampling proportion for registered voters who believe that gay and lesbian couples should be allowed to marry. Okay, so remember that's three things. That's mean, standard deviation, and shape. So if we wanted to find the mean of our sampling distribution, we could say it's 0.42 or 42% of registered voters. Our standard deviation, that actually we have to calculate, 0.42 times 1 minus 0.42 over our sample size, and the sample size is 50. All right, so we can see as the sample size increases just by this formula, we do see that our standard deviation will decrease. All right, and then you guys can punch that in on our calculator. And then finally, NP times 1 minus P, 50 times 0.42 times 1 minus 0.42. Calculate that out. It ends up being greater than or equal to 10, so we could say that the shape is normal. Okay, so let's go on to our problem, one that we're more likely to see on a quiz or an exam. So according to this study, the proportion of Americans who are satisfied with the way things are going in their lives is 0.82. That's pretty good. That's a B rating. Okay, so let's look at our keywords. Suppose a random sample of 100 Americans is asked, are you satisfied with the way things are going in your life? So this says, describe the sampling distribution of P hats. That's definitely a keyword. And they're saying P hat is the proportion of Americans who are satisfied with the way things are going in their life. And we have to verify the model requirements. Okay, so let's write down the information on top. The proportion of Americans from our population is going to be 0.82. And then N is going to be, in part A, 100. Okay, so let's verify the model requirements first, and we can see it at the top of this page. Do we have a simple random sample of some sort? Yes. So you can just write that out. I want to know that you guys checked for that. Is a sample of size 100 less than 5% of all Americans? Absolutely. That's nothing, right? Unless there's only, oh, I put 2 S's. Unless there is only, yes, what is that? 2,000 Americans, and there's many more Americans than that. So we're good to go. Okay, so we're going to describe the sampling distribution. So those are our requirements. We checked them. Now we're going to see if NP times 1 minus P is greater than or equal to 10. So there's our sample size. Here's our P. 1 minus P. All the Americans that are not satisfied with their life is 1 minus 0.82. And if we punch that into their calculator, we get 14.76. So make sure you guys do that calculation for me. And that is greater than or equal to 10. So remember to draw your conclusion from that. To get full credit, you would want to show your work and then say it's approximately normal. All right, and then we're going to do our mean of our sampling distribution, and it's just the population proportion. So 0.82. And then finally, the standard deviation is the one that requires more calculations. So probability of success and failure is what we used to call this. But now it's population proportion. All right, so we're plugging in our numbers, n times 1 minus n, p times 1 minus p divided by n. And you put that into your calculator, and we should be getting 0.03842. Okay, so let's continue on. So part B, from part A, what is the probability the proportion who are satisfied with the way things are going in their life exceeds 0.85? Okay, so let's do just a very quick sketch. All right, so we know that the mean is P. So there's your mean. So what's the probability from part A? The proportion exceeds 0.85. So maybe 0.85 is right here approximately. So exceeds mean we're going to the left. So probability is area. We already established this was a normal distribution. So we're going to look at area under the normal curve. So we're going to be looking at the probability that p hat exceeds 0.85 if we were to take a sample of 100 people. So that's your normal CDF. Okay, and I'm going to write the parameters down below. We're starting at 0.85. We're going off to infinity. The mean we talked about. It's that population proportion, so 0.82. And then standard deviation, let's not round. So if you were to take the radicand from before, if you were to just factor this out in a step, this would actually be 0.001476. So let's take that square root, and that way we're not rounding. It's better not to round to the very last step, because you never know how far off it will get you if you round too often. Okay, so we put that into our calculator, and then the probability ends up being 0.2174. So the probability that we get a random sample of 100 and that proportion is bigger than 0.85, the probability of that occurring is about 22%. Okay, so next, would it be unusual for a survey of 100 Americans to reveal that 75 or fewer are satisfied with the way things are going in their life? Okay, so unusual, remember that means the probability has to be less than 5%. All right, so this is a probability question. And the other thing is 75 is not a proportion. 75 is not a proportion. So we're not going to be finding the value of a random variable being less than 75, right? Because that doesn't take into account our 100 there. So we're going to be using our sampling distribution, and we have to create the proportion this time. And it's 75 or fewer, and 75 out of 100. So to use our sampling distribution of sample proportions, we need proportions. Okay, so this is really what we're saying. So is the probability that the sample proportion is less than 0.75, is it unusual? So we want to know if it's less than 0.05. All right, so let's see what happens. Let's take out our normal CDF. Less than means we're starting at negative infinity and ending at 0.75. And we have the same mean and the same standard deviation on the next line. All right, and then we put that into our calculator and we get approximately 0.0342. And remember what we're asking? We're asking if it's unusual. So is that less than 0.5%? Yes, it is. So we could say yes, it's unusual. All right, and then this is really what the kind of stuff we're going to be doing in Chapter 10. This is how we're going to be doing our inferential statistics. To try out a claim, we're going to take a sample and we're going to see if it's unusual or not. If it's unusual, like in this case, and we've talked about unusual events before, it means that it could be just by chance, or it could be that something is going on, something is wrong, or we'll say something is fishy. And when we're doing our inferential statistics, we assume that something is wrong. So for instance, since it's unusual, we're not going to say, oh, maybe it was by chance and it's fine. We're going to say, okay, this is showing us that something's wrong. So since it was smaller than 0.75, maybe this 0.82 was wrong to begin with. Maybe the 0.82 was closer to 0.75, something like that.